Homework 5, problem 12. Find the force between a neutral atom with polarizability alpha and a point charge Q. And so I'm going to have my neutral atom separated by some distance r from a point charge, and I want to find what the force between them is. Now the force arises, right, because this neutral atom induces an electric field. An electric field is radial, right? Okay. And this induced electric field is then going to polarize the atom. It's going to pull the negative cloud a little bit closer, and it's going to push the positive side a little bit further away. And so it's going to induce a polarization. We can then use the equation that we have for the force due to a dipole. Dipole is equal to the polarization dot the del operator acting on the electric field. Okay. And so we're simply going to have to find out what everything here is, but this is actually a pretty easy expression. The polarization, right? If we have polarizability alpha, is simply E times the electric field. So plugging that in, it says that the force of the dipole is alpha times the electric field dot the del operator into the electric field. So now we simply need what the electric field is, but this is simply the electric field of a point charge, which is going to be Q over 4 pi epsilon naught 1 or r hat over r squared. And here if we're thinking of, let's calling this the x direction, of course this is going to be in the x direction then, and so the ex, that will be partial derivative with respect to x, and so this expression here, this force, then is going to be alpha q squared over 4 pi epsilon naught squared. We're going to get a 1 over x squared, partial over partial x, 1 over x squared. But the partial derivative of 1 over x squared is, of course, negative 2 1 over x cubed. And so the force here is then minus 2 can be canceled with one of the 2's from the 16 on the bottom. And so alpha q squared over 8 pi squared epsilon naught squared 1 over x to the fifth, or r to the fifth r hat, if we go back to the radial language. And so it says it's an attractive force, which we knew just because the minus got pulled closer than the plus, so it's going to feel a stronger force. And it decays as 1 over r to the fifth. And that's it. That's your homework.